Very good morning to Ananda. I am Dr. Nallagumar, working as a professor under Department of Pharmaceutical Analysis at SNS College of Pharmacy and Health Sciences at Coimbatore. Today, we are going to learn about the Hplc, High Performance Liquid Chromatography. Once upon a time, we are used the outdated technique column chromatography. The column chromatography we are innovated around 80 years before. So there are so many drawback actually, particularly the particle size of the stationary phase, selection of mobile phase, and it is very lengthy process as well as a time consuming process. In this innovation in the instrumentation department, we brought the concept from column chromatography and at the same time the improved version we got the Hplc, high performance liquid chromatography. In this high performance liquid chromatography, we have major 5 compartments. The first one is the column. Here it is okay, we can see this column. This is stationary phase. The stationary phase made with Opta design silane here. And in this stationary phase, we have 2 types. In this RP-HPLC technique, we are using non-polar material as a stationary phase material, and this polar columns we are using polar compound as a stationary phase for in the normal HPLC technique. So anyway, this is for I selected today RP-HPLC technique. So this column stationary phase is made with non-polar compounds like Octa, Design, Silane. And another one is here the pump unit is, we have the pump unit used to create high pressure and like more than 3000 Pascal pressure level we can create. At the same time, here we have detector unit, PDA detectors we are using photodiode array. So it's functioning in this 3-dimensional concept actually. So we no need to select this lambda max for this any drugs. So it will scan entire range of ultraviolet spectroscopy 200 to 400 nanometer. Even visible range also we can add up to 800 nanometer. These detector will scan. And here this is the major data output unit we have the CPU monitor and everything. So we can preserve this data for the longer period, and the manipulations level is very less, and we will get very high accuracy data. And here this mobile phase unit we have. In this mobile phase we can use polar solvent or a non-polar solvent we are using in the HPLC. So normally, so just we will talk about this outline about HPLC, high performance liquid chromatography. So in this HPLC, here we have the pump unit, here we have detector unit, here we have stationary phase, here this is mobile phase unit, and data output unit we have. So this is injection port. So when we are injecting this sample, normally any compound we need to prepare 5 to 10 microgram per ml concentration we are preparing the sample. So 1 milligram is equal to 1000 microgram we know. From this 1000 microgram dilution we will reach up to 1 to 5 microgram per ml concentration we are preparing with the help of dilutions. In this dilutions we are using suitable mobile phase only as a solvent system. So when we are injecting this sample, so it will mix with the mobile phase, it will reach to the stationary phase, in the column. So when it was reaching in this column, it cannot enter or it cannot penetrate without high pressure. So that is the only reason with the help of this pump we are creating pressure. So this pressure can penetrate this stationary phase. This mobile phase can be travel in this stationary phase. Your sample also will travel along with your mobile phase. So here the concept how the mixed compound can be separated with the help of HPLC means based on the affinity, the basic concept. Okay, we are using here adsorption and affinity. No two compounds has same affinity towards stationary phase. If you have taken A and B, example paracetamol and diclofenac sodium, you are taken as a mixture, you are introducing here. So the paracetamol will travel within short period compare than diclofenac sodium. So why? No two compounds have same affinity towards stationary phase, and the same time the compound has high affinity towards the stationary phase, it will take more time for elution. And the compound has less affinity towards the stationary phase, it will take very short time for elution. So the paracetamol has less affinity towards the stationary phase compared to diclofenac. So that's the only reason. This paracetamol will elute in the 2.5 minutes and diclofenac will take 4 to 4.5 minutes. So after elution, so with the help of this PDA detector, we can estimate the quantity. So we are getting the graphical data here. In this y-axis we are getting area and x-axis we are getting RT. The area is directly proportional to the concentration. The concentration is directly proportional to the percentage purity or amount present in the sample. So based on the area, we can calculate the percentage purity or amount present in the given sample. So this technique is regularly we are using in the quality control laboratories in the pharmaceutical industry. So these high performance liquid chromatography applications is a number of applications it has. I will highlight a few applications here. We can perform qualitative analysis and as well as quantitative analysis in the pharmaceutical industry, and any kind of mixtures we can separate with the help of this high performance liquid chromatography. So like multivitamin compound or a multivitamin capsules has more than 5 to 6 active content in the single capsule. Such unit dosage forms percentage purity or amount present we can estimate with the help of this high performance liquid chromatography. Normal solid dosage forms like analgesic, non-steroidal anti-inflammatory drugs, kind of painkillers and other category drugs also. We are performing the quality control activity with the help of this high performance liquid chromatography. So the percentage purity we can estimate. Through this percentage purity we can estimate amount present, we can estimate. At the same time we can find out this purity of the compound easily we can identify. So here two parameters we need to consider. One is we need to select a right method. So first, before doing this assay with the help of high performance liquid chromatography, we need to develop suitable method for the HPLC. So this particular method is applicable for